Video 20. Permutations with repetition. Suppose if you are given three objects A, B, C, and you want to arrange, this is three objects, arrange two at a time. With repetition allowed means you can have A is one arrangement. Both can be same. This is what is called repetition. You can have B, you can have C, and then AB one arrangement, BA, CA, AC, BC, CB, like that. So this is what is called repetition. Previously we have permutations without repetition we have studied. There you have only these 6 ways. Now another 3 will come for 9 ways. So in effect we have 2 blank spaces. The first blank space can be filled in how many ways? 3 ways, because there are 3 letters A, B, C. Into the second place can also be filled with 3 ways. So 3 power 2 ways. Previously, without repetition means this can be filled in 3 ways. After filling one of the 3 ways, one object will go here. Here you will be getting only 2. 3 into 2 equal to 6 is the answer for without repetition permutation. With repetition allowed, 3, again the same letter can come in the second place and also 3 power 3. So similarly, if there are n objects and if we need r letters to be arranged, then the formula will be there are r blank spaces. Each blank space can be filled in n ways, n into r times n power r. If repetition is allowed, then the number of r permutations, that is a permutation consisting of r objects, r permutations of a set of n objects. So each object we have more number of copies, at least r number of copies. N objects means this is first object, this is second object, like that we have nth object. In each object, in each particular element, there are minimum r number of copies there. R number of copies of second object is there, like that. So therefore a set of n objects by the product rule is equal to n into etc. r times. This is equal to n power r. So there you will be getting npr when repetition is not allowed. When repetition is allowed, the number of permutations equal to n power r. So we will illustrate this by using a problem. How many strings of length are how many strings of length or can be formed from the English alphabet. Solution. Now here the problem is English alphabet, there are 26. First, second one, 26th one. Here many z are there. Already minimum r number of z must be there. Here r number of a's are there. Here r number of b's, minimum r number of b's are there. Now we have to select all r alphabets, maybe from A itself. So A r times. This is one string. That is repetition. All of them are A. That is one string. A coming r minus 1 times B is once, like that you can have many ways. So here the value of n is, here the value of n. How many different objects? There are 26. And r is equal to r combination. Therefore, this is something like we have n objects, we need r combinations, r blank spaces, rth blank space, first blank space, second blank space, etc. rth. So first blank space can be filled in how many ways? 26 ways. The same letter used here can be used there, therefore another 26 ways. Like that, 26 equal to 26 power r. Therefore, the desired number of r permutations. A permutation consists of r objects. R permutations is equal to n power r, which is 26 power r, equal to n power r is equal to 26 power r. So this is about permutations with repetition. The important concept is only combinations with repetition. Combinations with repetition. So for example, if you have three objects, we have to, this is n is equal to 3, we have to select two objects only, two objects, r is equal to 2, each combination, you can have a is one combination, b is another combination, c is another combination, and then you have AB is one combination, and then AC is another combination, AC and CA are same combination, BC is one combination. Totally you will get 6. That is, repetition is allowed. Combination with repetition. The number of R combinations, and if we have 3 different objects, then we have like this. So many A's are available. At least minimum 2 number of 2 A's, minimum 2 B's, minimum 2 C's, so that you can take all 2 from this group. The number of R combinations, the number of R combinations from a set with n elements. Each element has at least R copies available. In each element, at least R copies are available. In each element, at least R copies available. Okay. N elements. The number of R combinations from a set with n elements. When repetition of elements allowed. When repetition of elements allowed. Is equal to n plus r minus 1 CR. So the number of n is equal to 3 here. The number of elements in this sense 1, 2, etc. In each element at least r copies available when repetition of elements allowed. So anyway, we will explain how that n plus r minus 1 CR is coming in the next video. We will complete video 20 here.